Hello, everyone. Good afternoon. My name is Ana Carvalho, and as usually, I'm here today with my colleague Inês Almeida to present you with the R&D Sessions by EDP New. We are really happy to welcome you all here today for our 28th edition, which is actually our special season finale of 2022. So stay tuned for this. For those who don't know, EDP is the new R&D center. It's the R&D center of EDP, and we work on research and development projects on the energy sector. We work on European projects looking at innovative solutions for the decarbonization, the smartification, and the flexibility of the sector. And since 2020, we've been organizing these R&D sessions in a monthly basis. This is basically where we get together experts to discuss several topics regarding the future of energy, such as the challenges we're facing and the solutions that we are already putting into practice.
For today's sessions, we are going to dive into the topic of smart buildings and how they relate to the ever-growing need for system flexibility. And we will also introduce you one of the R&D solutions that is being deployed in this area. Let us remind you that the recording of each webinar is available on our website. You just need to read the QR code in this slide and you will be able to watch all the past sessions offline. For today's webinar, we want to encourage you to use our Q&A chat to ask your questions to the speakers. And at the end of the presentations, we will have the opportunity for have our speakers answering you. With no further delays, we welcome you to this event and wish you all a great session, but not without first introducing our moderator, Nuno Mateus.
Project manager, and he has a master's in energy and environmental engineering and a PhD in energy and sustainable development from the Faculty of Sciences of the University of Lisbon. In his PhD, Nuno developed research work on modeling and dynamic simulation tools in buildings and specialized in the area of natural ventilation and energy flexibility. By the end of 2020, Nuno joined EDP New as a project manager in the energy positive communities area, and he is now coordinating the Smart2B project, which is an H2020 project aiming at increasing the smartness of existing buildings. Nuno, thank you so much for moderating the session, and the floor is all yours.
Thanks, Anna and Inês, for the great introduction. So, in fact, I'm just trying to introduce our presentations of today. So before we move for the first speaker, I'm just sharing the overall agenda of today, where we will try to bring you different perspectives about how smart buildings and energy flexibility could be used for the energy transition. In this context, we'll have the first presentation from Hongling, that is in fact a work on the energy flexibility based on Annex 82 Energy Agency work. Then we move for André Cerny, that will present us the DSO perspective about building smartification, and we finalize with Brida from Vitu, that is currently working on Smart2B project, the project that EDP New is in fact coordinating, and will present us the concept of the project and the flexibility service that Vitu is developing in the context of the project. And we just finalize with our Q&A session. So please do not forget to place your questions on the Q&A chat. With no further delay, we can move for our first speaker, that is Hongling, that is associated professor at DTU Civil Engineering. She has been working on smart energy systems and smart cities projects and is currently member of the International Energy Agency Annex 82, based on energy flexibility buildings towards resilient low carbon energy systems. Hongling is also board member of the Horizon Europe R&D Partnership Build for People, contributing to defining the built environment research topic in Horizon Europe. And today will present us energy flexible building stores, resilient low carbon energy system based on the International Energy Agency work. So Hongling, the floor is yours. feel free to share your screen, please.
Thank you. I will share my screen. Okay, so I think you can read. Good. Can you see my slide?
Yes.
Great. Okay, thank you for the introduction, Nunu. Yes, it's my pleasure to present NX82 here. We are a group of mainly around 50 building engineers working on energy flexible buildings. This is a continuation of NX 67 that was ended in 2019. So I'm an associate professor at DTO Department of Civil and Mechanical Engineering and operating agent for NX82. As Nuno said, I'm also a board member for Build for People Partnership of European Commissions. So I will have 10 minutes to briefly introduce you to NX82. In NX82, we have 4 subtasks. Subtask A is about modeling of building clusters and multi-carrier energy systems. And for this, we mainly focus on cluster of buildings to work on aggregated level. So cluster of buildings, we also include zero energy neighborhood, for example, smart cities, positive energy districts. And we focus on using control signals for activate energy flexibility in buildings. I know there are other approaches as well, but here we use a price-based signal, for example. In subtask B, we have a team of 10, 12 teams working on common exercise. Here we use same methodology. In the first round, we used the flexibility function that was developed in NX 67. So different team test the flexibility function method using their own case study and their own data, whether it's simulation based data or smart meter data, to further develop this flexibility function method. And also we would like to eventually make the scripts currently developed in R to be more user-friendly. So this is the aim of subtask B. And in subtask C, we focus on stakeholders. So you all know they are large number of stakeholders engaged in demand response. And here we want to know better about the barriers and the motivating factor for providing flexibility services. So not only the end users, but also energy service provider and energy technology providers as well. For this, we would like to use a new inclusive method to engage users in the design of demand response solution. And the last subtask is about business models and also policy. Here, we have a rather small group of people working on this, as we are mainly engineers. But here we need people with a different background. We managed to have a group of people work on this. So we focus on looking into current business models, and we also want to look into whether they are difference in those business models across country and for different type of energy system. And we also look into incentivize systems which system is worked better, and collecting case studies and using interviews to understand and to gain more insight. So these are our work subtasks. So NX82 has started the working phase in 2021, and now we are in the middle of the 3-year working phase, and we are right on track. So we have finished the first common exercise. Now we have defined the second one, and teams are starting to work on the second one. And through this common exercise, we define methodology. We also start to look into case studies and design surveys and interview. And I will give you some details on this. So it's a rather big team. We have participants from 22 countries, and with about 50 very active participants working on these 4 subtasks. Some highlights. We recently published a 10 questions paper regarding energy flexibility in buildings. I and Andy from Lawrence Berkeley Lab was leading this task. And this one served as also a white paper for us to look into those questions when we work on specific tasks. So we have many ongoing activities that has planned to publish. For example, there's another review on energy flexibility in clusters of buildings led by Jerome and Rui. And this paper is in the revision phase. And we have another one working on energy resilience of built environment. So the work is also started. We are now doing literature review. And this one has been started about half a year ago, and we have 6 teams working on a very structured literature review on understanding customer participation in demand response, mostly focused on residential customers. And from subtask B, common exercise, we have had quite good progress, and we would like to show our progress in energy flexibility characterization method using a flexibility function for a large group of buildings. So these are a few work that is in pipeline to be published in coming year. Another tool I would like to say is that we're going to call for contributions for 2 survey study. One is on residential households participation in demand response. We are currently working on a questionnaire and in collaboration with a team in US, and plan to open this survey for contribution in March. And there's another template we are developing at the moment, focus on a business model. And so with the 2 purpose, one, we want to collect case studies on energy flexibility that has been demonstrated and shown that energy flexibility can create value. And another one is about pricing designs. We want to collect those information in order to provide a recommendation for legislation. Regarding the 10 questions paper we published a few months ago, I would like to give some highlights here. We discovered a few critical, of course, 10 critical questions we discovered and discussed, and then we provide 8 recommendations in the end for more research to put in. Some more details. The 10 questions I would like to talk about. First, what is the how can building energy flexibility contribute to a low carbon future energy system? Here we give a very good overview on the need of energy flexibility, and also provide some quantification on the impact of using energy flexibility. Then the second and third one are focused on how to quantify energy flexibility and how to harness energy flexibility. So quantification, and they are mainly two different type quantification methods. In this answer, we describe them, and we also discussed our next 67 method, that is energy flexibility function. And the energy flexibility function is a very good way to use when we consider to harness energy flexibility. So then we also discussed how multi-carrier energy system can contribute to energy flexibility. So then the conclusion is that multi-carrier energy system has a high potential for energy flexibility. And what about energy system resilience? Can energy flexible buildings contribute to energy system resilience? So our brief answer is yes. Although energy system resilience should be included in the design phase as well, but energy flexibility of buildings can mainly be harnessed during the operational phase. The next two is more about users, stakeholders, and who are the stakeholders should be involved in energy flexibility, and what are the new approaches that we can use to increase the engagement of stakeholders and increase their acceptance, for example. The next one is about requirements and the standards. So at the moment, there's no building standards that support the use of energy flexibility in buildings. We discussed that, and we suggest this should be changed. Then the last two are about business models and the policy. So in the end, we provide 8 recommendations on how to provide solution to these research questions. For example, the first one is using data-driven method and focus on aggregated level, considering the requirements from different stakeholders. In terms of control, we recommend to use a supervisory control that can respond to grid signals at the building and the grid level. And regarding algorithms, we discussed that more sophisticated building models and control algorithms are needed. That we need also take into consideration both energy efficiency and flexibility. The first one is very clear that it is a research problem. We need to engage multidisciplinary approaches to address this technical, economic, and societal complexity of the challenge. Then the fifth one is regarding resilience. Design flexible building system and controls that may contribute to more resilient systems when it is needed. So here we think that in order to increase the resilience of a system, the design phase is very important to include certain elements. And regarding policy and regulatory framework, we think that existing ones are not supportive enough, and we need to create a new energy performance standards that do not penalize flexibility. And the seventh, regarding business models, we think that scaling up is a very good solution for lower the cost of deploying energy flexibility. Business models can be developed that can support the scale up energy flexibility across multi-buildings and technologies. And the last one is about policy. Policy support is always very not always, most time is a very effective way to make things happen. So policy support to reduce technology costs here is very necessary. Okay, and yes, as I said, we're in the middle of the 3-year working phase. However, due to pandemic, we had only one in-person meeting in October, and that was a very good one. So we had a very good discussion. After that, we had a very good progress. And this is a group photo you can see, and this is us. Thank you.
Thanks, Hongling, for this great overview about the energy flexibility topic and to clearly give us the questions that should be addressed in the future in order to make use of the energy flexibility. So now we may move forward to our next speaker, that is Andre. Are you seeing my screen right now, right? So he's Senior Project Officer at EDSO and is currently managing the association involvement in European research and innovation projects, fostering integration of renewable resources, supporting consumer engagement and flexibility solutions for grid operation and digitalization of the energy sector. In addition, Andre has an educational background based on energy security studies and in power electrical engineering, and today will present us DSO's perspective on building smartification. So please, Andre, you can share your screen.
All right, so thank you, Nuno, for the introduction and for inviting me to this session. I hope you can see my slides by now.
Yes, you can proceed.
Cool. So yeah, as was said, I would like to introduce a little bit more the perspective of distribution system operators on building smartification. As I am not myself a smart buildings expert, yeah, this will be more general, high-level perspective, but I hope still bringing some additional insight. So on the agenda, what I would like to share today is yeah, the high-level context of smart buildings in the more general transition and the transformation of distribution grids that we are facing right now, and that will be the challenge for the coming decades. The potential of smart buildings for us grid operators, the specific challenges that DSOs are facing when trying to integrate smart buildings in networks, and the implications for regulatory framework and policies that might arise from these challenges. So let me start with the general context. I will present now a couple of slides that are taken from a study that we did in 2020, 2021. So just a disclaimer that these numbers here might not be completely up to date given the situation in Ukraine and general energy crisis, but let's say the trends that I'm presenting here will only increase, right? So as you can see here, we are predicting quite a steep increase in final electricity demand in Europe, rising sharply by about 2% annually. This rising electricity demand has some drivers that are presented also here. We can say that there will be significant addition of heat pumps in residential sector. Another driver is electrification of transport, so significant addition of electric vehicles, and of course renewable energy resources, right? 70% of the renewable capacity added is probably to be connected to the distribution networks. And here can we see that also 40 gigawatts of the renewable energy capacity will be actually self-consumption, so connected directly to homes and buildings. So these are the main drivers for the electrification trend. The challenge is that obviously we need to adapt our distribution grid for this, and this will cost money, which is shown in the graph here. You can see that this could amount to 50 to 70% increase of annual investments in distribution grids, which is a quite significant increase. If we break down the drivers of these increased investments, you can see that electrification of buildings, electromobility, and so on actually take up quite a significant chunk of the investment needed. But also, just to clarify that modernization of the grid equipment, digitalization, smart meters, which are also loosely connected to the problem of building smartification and electrification of appliances in buildings, also take up quite a lot of the investment needed. So what is the actual potential of smart building smartification for DSOs in trying to address this significant increase of electrification and decentralization of energy system? As you can see, the potential is mainly related to the networks on the low and medium voltage level. So actually we see in the shorter term, we see the potential mainly in increasing the grid observability for the network operator, firstly. So this can help managing the low and medium voltage networks, where the grid observability today is not so developed as on the higher voltage levels. And in the more long-term perspective, obviously getting more data on the grid and behavior of the grid users can improve the network planning and therefore also drive down the cost of network investments. Secondly, we can see that this smartification of buildings and the data that will be available for the consumers can function as a self-regulating instrument for the consumers when they get more information about their energy consumption. So this is something that a benefit that will basically materialize even without any action from the DSO side. But also it can help a distribution network operator to provide and design more sophisticated incentives for changing consumer behavior now. This can take a form of dynamic network tariffs, but the ultimate goal also in line with the European legislation is developing flexibility markets open for all participants. So consumers, active consumers, and so on. And the technical level, developing smart buildings also could provide a platform to enable direct control of devices connected behind the meter. So be it charging points, batteries, and so on. Enabling also participation for the consumer in multiple energy markets, balancing markets, and so on. Therefore, bringing more value to consumer and again, driving down the cost of the energy system. Here, this is just another example of the principle how the smart buildings can actually drive down the cost for network operators. So we can see that basically just by introducing incentives for off-peak charging of electric vehicles can actually drive down the load in the network to that point that we can defer network investments in enhancing the grid capacity to the later point and solve the congestion problems directly without lengthy building of new lines. To enable this, we obviously need to develop a new ecosystem for the medium and low voltage grids, especially with connecting all the elements we just described. So network operator, all the devices in smart buildings, and developing also the digital infrastructure that is necessary to achieve this. Some of the specific challenges that the DSOs are facing right now when trying to develop this ecosystem are described in this slide. So first one, I named finding business models and engagement of active prosumers. This is related to the point that all these smart building applications are quite new. The consumers are not so familiar with the options that are available. So the prospect of participation in flexibility market might not be so attractive for them, for the consumers, as they actually don't know what it means. It's not clear for the consumers in our experience that this can mean driving down the costs of energy. So this is something that needs to be worked on, consumer engagement. It also is about the investment certainty, as all these smart appliances in homes and buildings are quite big upfront costs to invest in. But if we would have flexibility markets, it's a market environment, and revenues from this are not so guaranteed. So we need to strike a balance between investment certainty for the participants and having liquid markets that could actually also bring the required benefits for DSOs for local congestion management, for example. Second challenge that is needed to be kept in mind and really tackled before is avoiding a technological lock-in in any particular solution for smart buildings and the data exchange models and so on. So having standards for interoperability of data exchanges, home management systems, and interfaces with distribution system operators systems is very important. And we also believe that open source approach is important to facilitate open development and open competition also in the development of different solutions. Thirdly, I wanted to talk about the importance of governance for data and the role of all the devices on the grid edge. So all the devices that can potentially participate in energy markets. One imperative part is that DSO must remain the guarantor of accuracy of the data, as we can see that the ecosystem will consist of many different solutions, many different platforms that can compete together and provide different measurements for the consumer and for the system operator. It is imperative that DSO remains the one sole guarantor or of the reliable network measurement data. So the maybe a little bit crude drawing in this slide is meant to symbolize this. So we think smart meters should be the central point for the official measurements and the correct measurements for settlements, for example, of flexibility markets and so on. Smart meters can also function as providers of DSO control signals for the energy management systems or even the connected devices. The other data can be useful for network operators as well in supplementary role in enhancing grid visibility, improving network planning processes, and so on. But it is important for us to have this central link kept still in place. And now to my last slide, where I put down some recommendations that should be followed up to successfully integrate flexibility and smart buildings in network operation. Firstly, it's about the money, as I already shown. So we definitely need to enable DSOs to make the necessary investment. So we need to change the tariff structures to enable investments not only in grid reinforcements, but also in all the necessary grid smartification. The second point is to introduce regulatory incentives that would enable the development of flexibility markets. So firstly here, I noted that it is necessary to finally transpose all the provisions of clean energy package into national law. Secondly, we need to facilitate regulatory experimentation, so sandboxes, regulatory sandboxes, and other instruments to enable to finding the best solution for the flexibility markets. Promoting detailed consideration of buildings' role in network planning would also help, and as always, continuing supporting research and development activities is quite important to find a best solution. Next point, developing regulatory framework for flexibility. Some of the most important elements are mentioned here. So it's definition of roles of all the actors in the flexibility markets, economic signals, data exchange procedures should be developed on European level with particular regard to the specific national level situation. So probably it needs to be layered into a national and European approach. And thirdly, the last point here is that DSO must indeed remain the central guarantor of data reliability in the ecosystem. So this role of the data reliability guarantor should be codified better in the regulatory framework. And these are my recommendations. And with that, I'm finishing my presentation.
Thanks, Andre, for your overview about how we can integrate smart buildings in the flexibility market. So with no further delay, and we'll move for our last presentation of today. So will be made by Brida Buir from Vito. She holds a master's degree in electrical engineering for smart grids and a PhD in electrical engineering, whereas thesis focused on data-driven control for residential demand response. She's currently working on Vito and Energieville in Belgium. Her research works are mainly in smart grids, demand-side management, optimization, machine and reinforcement learning for energy flexibility management. And today she will bring us the presentation about the energy flexibility from existing buildings that comprise the work that Vito has been doing in the context of the Smart2B projects. So Brida, you can share your screen, please.
Can you see my screen?
Yes, but not in presentation mode. Yeah, now it's fine.
Okay. So thank you very much, Nunu, for the introduction. and I will be talking about the Smart to Be project and specifically about the work we are doing on energy flexibility from existing buildings. So as we all know, a lot of buildings are responsible for the high share of energy consumption, and as such, they play a key role in the energy transition. But the challenge that we have now is that most of these buildings, they are passive and they operate inefficiently due to the use of very little or no energy management systems for optimizing the energy usage in these buildings. And some of these buildings, they have quite some flexibility potential, but this flexibility is not currently being exploited. So the goal of the Smart to Be project here is to develop devices and services which can be used to upgrade the smart readiness levels of these buildings, exploit the flexibility that they have, and turn these buildings into active energy nodes. So in this regard, Smart to Be is developing different services that are aimed at assessing the smart performance of the buildings, exploiting also the flexibility from the existing resources in these buildings, maximizing the use of local generation when this is available, and all this while ensuring and improving the indoor comfort of the users in the building. So diving into the flexibility aspects of these buildings, so in the context of the Smart to Be project, we have actually two main sources of flexibility that we look at. So we have flexibility from energy storage devices such as electric batteries, and also from thermal energy storage, such where we look at the flexibility via heat pumps and attributing this flexibility to the thermal properties of, for example, hot water tanks and the thermal inertia of buildings. Then we also look at flexibility from shiftable loads. So these are devices whose operations can be delayed in time. And these we look at electric vehicles. We look also at wet appliances such as dishwashers and washing machines. But then the question that comes to mind now is how much flexibility can we get from all these devices that are found in buildings? So we need to somehow find a way to quantify this flexibility such that it can be used for something. And to quantify this flexibility, we are using this concept of flex graphs. So a flexible device has several options in time that it can consume or produce energy. So this leads us to having an energy consumption or an energy production plane. So what a flex graph does is to visualize the area between the highest and the lowest path of this energy consumption plane, where the area of this graph then tells us how much energy can be shifted, and the number of possible paths within this plane or within this area tells us the potential to shift the energy consumption or the production. So depending on how large the area is, on the number of paths that we can find within this within this energy consumption plane, then we can have an idea on the exact amount of energy that we can shift and the number of different ways that we can consume this energy, or that the device can consume this energy. So looking at the flexibility that we can get from the different devices, or the devices that we are looking at in the Smart to Be project, if we take, for example, an electric vehicle, there are two main things to take into account when we look at how much flexibility they can offer. So we look at, okay, when the owner of the electric vehicle plugs the car onto the charging pole, if we charge the car as soon as possible, or if we delay the charging as much as possible, but while making sure that by the end of the day, when the user has to leave, that the energy that was requested on arrival is met. So then we can have an energy consumption plane, as the one shown here on the slide, which we can then use to quantify how much flexibility we can get from this electric vehicle. If we look at a hot water tank, then the flexibility here to generate the flex graph here, we look at the different ways of either keeping the water in the buffer at the minimum temperature, such that if the water leaves the tank, then the users do not perceive the water as too cold, or if we keep the water in the buffer at the maximum temperature, such that if the water leaves the tank, then the users don't perceive it as too hot. So based on this, then we can generate a flex graph for the hot water tank, and we can then quantify how much flexibility we can get from this hot water tank. Then we also have flexibility that can come from the thermal inertia of the building itself. And typically the flexibility from these buildings is usually represented by the temperature boundaries that is being specified by the users of this building. But then the challenge that we have here is that if we want to use this flexibility which is coming from the thermal inertia of the building, with the flexibility from the other devices, then we need to map this from the temperature plane into an energy consumption plane. And to do this, we need to kind of model and characterize the building behavior such that we can then determine the additional amount of heat that the building can store, and therefore the corresponding reductions in energy for heating or cooling these buildings. So in the Smart2B project, to model these buildings, which we need to generate the flex graphs for the building, we use these gray box models of buildings. So a gray box model actually is a very simplified way of representing the building, where we lump and represent the different building components as thermal resistances and capacitances. So here we kind of exploit the physical knowledge of the building to define a model structure and then some state equations of the building. And together with some weather and building measurement data, we can generate or determine the parameters that are much more representative of the building that we are considering. So this notion of flex graphs is actually a very simplified and generic way to quantify and represent flexibility from different devices and installations. And it's also very good because then it's very easy to aggregate flexibility from different devices, different buildings into a single resource, which could either be used for energy cost savings or for local congestion management, as Andrej mentioned in his presentation. So to valorize this flexibility, because of course it's of no use if we can quantify this flexibility, but we cannot use it anywhere. So to valorize this flexibility, it's typically done through demand response applications. And there are two types of demand response. So we have the explicit and the implicit demand response. And in the explicit one, you have where the devices that are providing flexibility can be directly remotely controlled, and typically by an aggregator or a system operator. And this is typically done with large manufacturing industries. Then we have the implicit demand response, where there is indirect load control through a time-varying energy price signal. And this is very common at the building and residential level through the use of energy management systems and controllers, which is what we also consider in the Smart2B project. So to have an economic value of the flexibility that we model and quantify in Smart2B, we actually use this by scheduling the operation of the different devices that are providing this flexibility. So we do this via optimization, where we consider not only optimizing for least energy cost, but also looking at the least energy consumption. So we have a kind of approach where we first have an optimization for least energy consumption, specifically for the HVAC systems in the building. And this provides us with a baseline schedule, which is then used in the flexibility modeling to get the flex graphs and quantify the flexibility of the buildings. And this aggregate flex graph and the baselines are then used in the list cost optimization to obtain an optimal power schedule that is then disaggregated to the different devices in the building as the control signal here. So in addition to like using this baseline and the flex graphs for the optimization for list cost, we also use some forecast on the energy prices and the energy generation, which helps us to, as mentioned before, the goal is that if we have some local generation on site at these buildings, then we also want to maximize the use of the local energy generation. So when we do this optimization with the optimal power schedule that we get, we can then actually quantify the value of the flexibility that we get from the different devices through some form of energy cost. So to conclude this presentation, so actually our goal in this service is to develop a very generic and simple tool for flexibility aggregation, such that we can actually aggregate the flexibility from different devices, different buildings, such that the building owners themselves can use it for energy cost savings, or that the system operator can also use it for congestion management. As shown in the previous slide, we see that in our optimization, we have like some forecast, which means we can never have a perfect forecast, so we have some uncertainties. We also have to take into account the user behavior. For example, when you generate the flex graph for the hot water tank, you need to take into account the hot water demand of the building, and for this we also use a forecast. And this user behavior is very stochastic. So it means that when we valorize our flexibility through optimization, there are a lot of uncertainties that we need to take into account. But this is a challenge, but this is also an opportunity that we have used. And right now, the idea is to have like a recurrent model calibration to update the model parameters such that we can account for the model mismatch in the model parameters. Another way in the optimization that we try to deal with this is that we use this data-driven optimization method, reinforcement learning, for obtaining the optimal power schedule. But of course, because these data-driven methods, they are always quite data hungry, we still run into the challenge of the availability of data, because also we are relying on data from the pilots, which takes quite a while for us to get quite some good amounts of data that we can use for the optimization. So thank you very much, and your questions are welcome.
Thanks, Brida, for your presentation and also for giving us an overview about the flexibility services of Smart2B. Now we have time for some questions. I know that we already have some in place, so just pick it. So first of all, from João Cravinho, I think, for just because I just missed the question. So from João Cravinho on the chat, I think it's for Hongling. In your opinion, what is lacking or missing for the realization of local or wider flexibility markets?
Thank you for the question. I think the second speaker in his presentation gave a lot of hint on the answer to this question. I would like to add something on it. So certainly the uncertainty of energy flexibility is something hold back investors to put money into this business. But I think another perhaps Another improvement we as researchers should do is to simplify this matter. What investors, general public want to see is a number. What is the flexibility? Can you give me a number? So if we could simplify this matter, see this is how much flexibility, we shouldn't do. We should do with confidence using our knowledge from pilot study, for example. And I would say make the quantification of energy flexibility simpler, provide a number that is easy to communicate. And in this case, I really recommend using flexibility function, not only because it's developed by ourselves, it is really a very good method to when you work on large scale on the aggregated level. So it's a good method for the DSO to plan energy to actually design energy price, for example. What is the effective price that can encourage people to shift their peak demand, for example? So using a flexibility function, we can actually do this type of thing. Another thing I want to say is that we need to go a step further, not focus on quantification of flexibility potential. We need to look into data-driven method to go towards how to use smart meter data help us control energy flexibility in buildings and aggregate this energy flexibility. So this is a critical thing we as researchers should do. And I would like to also give an example. This winter in Denmark, the households have access to real-time price. This is hourly price. So 50% of households are on the constant price contract. So they don't check. They have the same price all the time. But 50% households has hourly price. So basically you can see very big difference between peak hour that is normally in the evening and the morning. Evening from 5 to 8. The price of the peak hour price is 4 or 5 times higher than the lower valley price. That is normally from 2 a.m. to 4 a.m. And you can see there's a very big peak load shifting, and statistics show 10% of peak load reduction. Is because 50% of household look into this price and shift their electricity consumption. And in general, there's also 10% energy saving. So we use 10% less electricity this winter compared to last winter. This is also due to higher price. So this is a real case that make us really think price signal is a good signal to use when we want to control or activate flexibility from buildings. Yeah, this is my answer, add on top of the summary provided by other speakers.
Yeah, thanks, Hongling. Now we can pass to the next question for Andre from Humberto Queiroz. Is it already feasible in practice to use distributed generation and or electric vehicle fleet to protect DSO's assets and postpone investments in the grid?
Yep. So I would say it's definitely already happening, and as was already mentioned by Rongling, the current energy crisis did quite increase the interest in this and interest of consumers in checking their behaviors according to the prices. So it's one of the maybe unfortunate effects of the unfortunate situation. So we can see, for example, in Netherlands, our colleagues are reporting to us that they have huge problems with connecting new renewable energy devices and, for example, so connecting charging points for electric vehicles into the distribution grids. And this can be only done now using these kind of flexibility platforms and flexibility flexibility solutions, because otherwise the capacity of the grid is at the maximum. So I would say it's already happening. Whether it's practical or not, I would say the problem is more that these are usually local solutions. We don't have a European solution that would be really interoperable together and would enable also, for example, using this kind of flexibility for also the purposes of transmission system operators, the network management, so for balancing services and so on. So we need to build this additional interconnected layer on this that would truly open the potential of smart buildings and other flexibility devices.
Okay, thanks, Andre. Now we move to Miguel Brito that make a question to Brida. Based on your experience in Smart2B or other projects, how difficult it is to convince the users to make use of their flexibility, and how are you convincing them to allow you to control their equipments? Are you using any user engagement strategies in the project?
So for convincing the users to make use of their flexibility, actually now with the current energy crisis, we get a lot of questions from people who want to know how can we get smart control devices, or how can we get building energy management systems that can help us to manage the energy consumption patterns at home. So I think now with the current crisis, a lot of people or a lot of end users are now very keen about this. So it's quite easier to convince them to use energy management systems and the flexibility that they can get in their buildings. Of course, one question that we always get is people asking if they have to change all the devices in their homes to be able to use flexibility. But this is something that in Smart2B, we are actually focusing on using flexibility that is from existing buildings, because this is very expensive. And yeah, people now it's very easy to convince them that they can do that with the energy crisis. And for convincing them to allow us use their control, use control for their equipment. Yeah, also now, again, as I said, as I mentioned before, yeah, everyone is quite keen now about how they can have energy cost savings. So I think now it's really the time that we can exploit these moments to actually get to test a lot of things on these smart energy management systems that we are developing. And within Smart2B, I think that we have also organized some workshops to try to explain to end users about the upgrading the smart readiness levels of their buildings, what are the advantages and what it could bring for them, to create also awareness.
Okay, Brida, so let's move for the two final questions before we close the session. From João Mateus, I think for André also again. The expected growing of EV are bringing to the table V2X solutions, flexibility, and specific management systems are being developed to control EV charging. How are you seeing the interoperability between V2X management strategies and the rest of the building? I think, in fact, it's an open question for all of you, so feel free to.
Yeah, from my point, I would say that I don't have an advice about the management strategy that would be the best. From me, I think the most important part is that would be great to have all the possibilities. So have separate management of these different assets at buildings, but also have the possibility to have aggregators aggregating more devices together. So the bigger variability, the better, because it brings additional liquidity for the flexibility markets and flexibility schemes, which is quite important for the network management, especially on the local level.
Brida, Hongming, do you want to add something on top of Andre's reply?
Well, I would not add anything here.
Okay.
Thanks.
Yeah, I think again the idea is for us to be able to kind of have a common ground that we can aggregate the flexibility that we can get from the different devices in a common resource that can then be used. So we need a kind of common framework that all the devices can be able to talk to each other, a common framework that we can represent and quantify this flexibility. And then, yeah, we can have the flexibility from the building as a single resource that can then be used for different purposes.
Okay.
I sort of disagree with this approach, but yeah, but I don't think this is the time to discuss this.
Okay.
Yes.
Maybe we create a dedicated session just for that.
Yeah, we can take it offline.
Yeah.
Now we can move for the final question before close the session, also for Andre, but of course it's open for both of you also. How do you find the application of blockchain technology for guaranteeing data reliability in the decentralized ecosystems instead of having a central guarantor?
Yeah. I think maybe my presentation wasn't that clear in this point. I think the DSO still needs to keep the role of guaranteeing the measurements reliability, but there is quite a wide field of application for technologies like blockchains behind that. So I think it's a complementary system, but for the central role of reliable network operation data, I think DSOs are not ready to adapt it right now or in the next near future.
Okay, thanks, Andre. I think it's now time to close our session. Thank you, Brida, Hongling, and Andre for your great presentations, also for the replies to the chat, also to the audience. And now it's time to move again and pass the word to Ana and Inês just to close the session of today. Hope you have enjoyed.
Thank you, Nuno. Thank you all for joining us.
Yes, we have just reached the end of our event and the end of this year's R&D sessions. As you know, this session will soon be available on our website for you to revisit. So Inês and I want to thank you all in the name of EDP New. Thank you everyone for your active participation and for being with us throughout all the events throughout the year.
Yes, let us remind you that next year we are coming back with a new and renewed season of the R&D sessions by EDP New. So stay tuned for what's coming. And for now, have the most amazing holidays and a happy new year. Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thanks.
Bye.
Bye-bye.
Bye.
Bye.